Okay, I think we can start.
Hello, Sylvia. You can start now. I already start recording. Okay.
Okay. So how is my sound? It's okay?
Yeah, it's okay.
It's okay, great. Any noise around me? Yes, no?
No.
Great, excellent.
Thank you.
So, yeah, but I didn't see anyone. I don't know, maybe my internet connection is not very good. Oh, yeah, I see. Hi, Ghazali.
Hi, Smita. Good morning.
Morning. Good day in Malaysia.
Evening.
Oh, evening, yeah. Okay, so I see some participants has joined to us. Guys, you can turn on your cameras and say hello together.
I think you should see the chat area also.
Sorry, what do you mean?
Open the chat,
Chat.
the chat box. Yeah, the chat area. There you can see the rest.
Yeah, hello everyone. Hi, Bruno. I think I have found the most early country in our camp, Bruno from Brazil. In Brazil, now it's 4 a.m. o'clock.
Oh,
Yeah, it's amazing. But he don't sleep. He doesn't sleep. He's hero.
I'll take a print, like a print screen, like a photo shoot here. So please, all of you, open your camera and smile.
Oh, great. Oh, hi, Bruno from Portugal. Hi, Bruno. How are you? Oh, hi, Jack. um, Hi, Stotam. Yeah. Great, guys. Nice to see you. So I think we can make common photo, morning photo training.
Yeah, after a minute we will do, but please, everyone, be ready. Open your camera and be ready, so everyone look okay.
Yes. Please take a photo on 3. 1, 2, 3. And
Yeah, okay.
in this case,
Okay.
we will be ready.
Yeah, okay. Now, okay. Mamdo, could you please look at the camera? We'll take a photo. Okay. 1, 2, 3. But I think it's not a high resolution. Not a good resolution. Try again.
Yeah, great smile. Bruno, you have a blur on your background and bokeh.
Okay, so
Okay,
you can start now. If you are ready, you can start
great,
now.
great. I think we are ready. And now I'm going to share my screen. Yeah. Okay. So I hope you see my screen. And great. And welcome to our second day of our World Skills Asia training and drone operating skill. And I have some news for you. During the last day, uh, some people has joined to us. Team from Brazil, team from Singapore, team from Malaysia, and United Arab Emirates. A new team, a couple of team joined to us. It is amazing skill or amazing camp. Great news. We extended our our influence on the world. I think it's great. So. Today our second day, and today we will tell you about gazebo simulator environment and provide the first introduction with this platform. Okay, so let's introduce with you our organizing team for next days. Yulia, Timofey, your teachers. They will help you and provide educational materials and tutorials working with Gazebo platform. Artem Batalov, he will help you and answer to your technical question in the chat in our common group. If you have any question about communication or etc. organized problems, you can ask me or Ilya Huhuni. And of course, our my favorite team, Elena Silverstone and Victoria Trubitsina, they help us to provide some technical side and provide reflection and collecting feedback. Don't forget about leaving the reflection during the camp. Okay, so also I would like to remind you about our camp schedule. We will start every day up to 22nd from 10 and up to 1 p.m. by Moscow time. Tomorrow and after tomorrow, we will provide some task with assessment. Also, for our meetings, we will use this link for this Microsoft Team platform as well. Yes, and of course, don't forget about homework. Homework will be every day. And today we will check your homework. Thanks all of you who provide a pool, who leave the void. And now I would like to offer our excellent students, Jacques and Mustafa, to demonstrate their homework and maybe tell us about how they to solve it. So, guys, what do you think about it? I can make a surprise. Have a special skill of it. So, guys, what do you think? Are you ready to demonstrate your homework? Mustafa, don't worry. Don't panic. I know that you are performing the homework with using Gazebo Simulator, using writing a code. So I think it will be interesting to share your experience to us, to our group. you can share your screen and say some words about it, if you want, of course.
Okay, can you guys hear me?
Yeah, we hear you. Oh, hi, Jack. Yeah.
Hey, hi.
Great.
Okay, I'll try and share my screen. Can you guys see that screen?
Yeah. Before you start, please tell us about homework, what need to do, and how you to solve it.
Okay, cool. So we had to calculate how far the distance is between 2 points, and then how long it would take to fly that distance at a speed of 2 meters per second. So I don't know. Can you guys see my screen there?
Yes, we see.
This came back from a search.
Okay, cool. So should I just step through the code and explain what it's doing?
Hey.
Yeah, sorry. Can you guys hear me properly? Is my mic a little bit soft? Hello?
Yeah, Jack. Yes, you will continue. It's okay.
Okay, cool. So I start by importing the math module so I can use the square root function. And then I define the points. So those points over there, 0 0.3, 2.63, and 6.5, 2.2, and 3. And then I just define velocity as a variable as well, so it can change whenever. And then this distance, I work out, it's a bit packed in there. So if you wanted to unpack it, it's basically just x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared, all square rooted. But I'm just using the zip function so I can loop over both of the lists at the same time. If you wanted to, you could write it separately as
You performing your homework
Yes,
on the
I was
desk.
just trying to like explain exactly what's happening there because it's a bit dense, but I'm basically doing that just using variables instead.
Well, in this particular case, you don't need to use abs as square root is. When you have square, it always.
Yeah. Sorry. Yeah, that's right. Forgot about that. And then you can then use the square root of that. And that's why I import the math library. And that's your distance, really. And just distance divided by velocity will give you time taken. So then I just printed it out using a format string over here. Is that is that okay? Do you need to explain anything?
Okay, you have a little time, not more.
Okay, no, it's fine. I don't think I need to explain anything else.
Okay, okay. Thank you, thank you, Jack. And Mustafa, could you share your screen and demonstrate this code on the simulator, maybe how you check this homework?
Can everyone hear me? Can you see my screen?
Great. We
Okay.
hear you, but not we don't see your screen.
You don't see my screen.
Yeah.
Okay. Uh, you don't see my. Okay. Wait a second. How about this?
No.
No.
No. No. Yes. Yes.
Yeah.
It was delay. Sorry.
Okay. Can you see my screen now?
I think
No,
that
not yet.
not yet.
Okay.
No.
Uh, do you have my code? If you can open it, I can explain
Oh,
it.
great, great, great. We see your screen.
Okay.
Yeah.
Awesome. So what I understood from the task that we need to move to navigate the drone from point A to point B and calculate the distance and the time taken to fly from first point to second point. So I'll not be explaining the part to navigate the libraries and stuff. I'll just be explaining the code. So basically, in the beginning, taking off, the drone needs to take off to the height of 3 meters, then navigate to the first point, which is given in the task. After that, navigate to point B, then calculate the distance. There are two ways to do this. Either do it real time by getting the telemetry of both points and the time at each point and calculate the distance from that, or use simple mathematics to do that. That's what I did. That was the easier solution, so I did that because I didn't have much time. So getting the distance between 2 points, simply get the distance, which is a straight line, by getting the square root of the square distance from the x point axis and the y points. Uh, that's how you get the distance. So using the math tool, square root of 6.5 minus 0.3, which is the distance between both points, then getting the difference of y and squaring that. And the flight time, simply the time is distance over speed. The speed was given as 2 meters per second, so simply calculating that, and then after that printing those results into the terminal, then landing at the same point. Unfortunately, I didn't have enough time to run the simulator, but what I did yesterday was run it on the simulator, and that's here. You can see the distance. I don't know if you can you still see my screen?
We see your screen. Yes, for
Okay.
now.
Okay. Okay. So this part is where the code ran, taking off, navigating to point A, point B, then displaying the distance, which was 6.2 meters. Flight time was 3 seconds, and then landing. And that's it. I think that's about it. Does anybody have any questions?
It was homework for today. because I think you just write easy code on Python like Jack, and after it we will write it in Clover for Clover, and after it we will run it in Gazebo. But you make it today. You finish our today's task early.
I think Mustafa can get bonus task
Yes, yes.
for today. Okay, great. Thank you. Thank you for your sharing experience, for your performing the task. So I think we can start our classes day for today. And let's welcome Yulia and Timofey. You can start our lessons for today. And good luck, guys, and have a good mood.
Hello, everyone. Can you hear me?
Yeah, we hear you.
Great. All right. So, Yulia, will you start the presentation?
Yes, I started. Can you see it?
Yeah, we see it.
Okay, very good. So let's start. I think this lesson will the same like at previous skills camp, but it will include more practice things in Gazebo simulator, and we will work in Gazebo a lot today. So I hope you install it successful on your computers. If not, and if you have some problems with it, we can try to check it in our time for relax, and or after our game. So let's start. At first, I want to discuss navigation system because it is very important to understand how drone can understand his position in real world, and how it can get it accurately and with big accurately. So the most popular navigation system is GPS, of course. We have a lot of satellites, and we can get signal from it and calculate position for drone or for maybe car or maybe for your phones. So it is very popular and very useful navigation system, but it has one problem. It can work only outside, and sometimes it doesn't work accurately. For example, if you have bad weather, or maybe if you have different obstacles, it can give big errors. So we can use it in inside in buildings, and we need some another navigation system for indoor flights. It can be, for example, motion capture systems when we have a lot cameras in some area, and these cameras can check position of object in this area and calculate it very accurately, maybe up 1 to 5 centimeters accurately. And this system is very popular for example, in laboratories of Rafael de Andrea. It is the most famous laboratory who create autonomous drones, I think. And they use the system very often, but this system is very expensive because each camera can have cost maybe $1,000 or $2,000, and we need 3, 5, or 10 cameras for the systems. So it is very expensive. The same way, you can use maybe ultrasonic sensors for navigating and get drone position with it. But you need a lot sensors, a lot wires for it. One way to get position of drone, what is very easy and very very useful for education. It is navigation with camera. For example, it can be Aruka markers navigation with Aruka markers, or it can be optical flow, for example. So it is very cheap and very easy to start system in any area. For example, you can put markers in classroom and start autonomous flight, or you can just take drone with camera and start flying in any area with optical flow. It is system what's allowed to you start autonomous flight indoor easy. So we will use for our flights navigation with Aruka markers. So how it works? We have some squares with black and white points, pixels. And drone knows their size and size between two markers. So it can calculate his position from markers and his height from markers too, because it knows the size any markers, and it know where this markers is on the floor. So one very important thing, all markers should be different, because if drone will see two same markers, it will calculate his position incorrectly. And I think Timofey can tell a little bit more how we can calculate our position from this Aruka map. Timofey?
Okay, you can see on the picture, here we have a few coordinate system like X, Y, Z coordinates. And on the right side, there is a representation of drone's position in 3D space. On the left side, you have the camera image from the same moment of the time. And as you can see, there is XYZ coordinates on the floor, and they come from particular point on the floor. And this point is the original point of this frame of reference that we are using. And the frame of reference here is called Aruka map, of course, because these are Aruka markers. And well, the drone can calculate its own position relative to this arc markers field, the map, and it can show us where the original position is located. One more frame of reference. Well, frame of reference, for those who don't know, is the coordinate system. Well, one more frame of reference, which is a little bit, well, which starts when the drone is turned on, even without seeing arc markers, is called map, just map. You can see on the left here, it's in parentheses. The map frame of reference, it is calculated only by, firstly, it's calculated by internal sensors like accelerometers and gyroscope, and then it is adjusted according to the Aruco map once Aruco map is visible. So when you fly over Aruco markers, you can be sure that map coordinate system will not shift against the Aruco map, but you will not use this this frame of reference just yet, in our course at least. The next system is called the body. And for those of you who have already programmed drones, you know that you take off with body. And what body does is it calculates, when you navigate against body, you always provide coordinates relatively to the drone itself. For example, if I want to go forward, it means I need to navigate along x-axis, no other axis. For example, x2, y0, and z0. And here on the left bottom, you can see the navigate target system frame of reference, and this frame of reference is, you can think of it as of a better body, because it doesn't accumulate error. If you build some complex route, complex path for the drone, and use only navigate target frame of reference, you can be sure that the drone will stay on this road without moving too much because of some wind or other issues that can cause drone to shift from its path. And whenever you want to use, whenever you want to provide coordinates, coordinates from the position of the drone, you better use navigate target, not body. So body is only used when you take off, and if you take off several times during the flight, you will use body several times, but no more. So we can go to the next slide. Yeah, you can see on this picture the visual representation of where all of these frames of reference derive from. And here on the left bottom, you can see that this is our Aruco map frame of reference. Is originated from left bottom corner. And on the top right, you can see the drone. And it has its own axis, z-axis pointing up, y-axis pointing left, and x-axis pointing forward. So these are actually the coordinates. This is how axes are located in body frame ID. The same, well, yeah, the body is always this way. But if you want to use navigate target, it will align the axis a little bit differently, but you will notice it later when we start using navigate target coordinate system. So those are just a few frames that you need to know to start programming drones and use the most powerful features that we can offer you. So we can go to the next slide now.
Okay.
Oh, yeah. This
Yes.
is Linux commands that we will need to use today, because now you all of you have the simulator, the Linux environment, and you will use some of these commands during this course. So we will demonstrate you how to use them live, and we will also ask you to run simulators on your own to test this with us.
Yes, it will be cool if you can start your simulator. At first, I think I explain these commands. If somebody knows it, it's very good. If somebody doesn't know, don't worry, you understand it when we start work with simulator. The first one is cd command. It is a command that allow us to change directory. For example, when we want to open some folder in our screen in Windows, or maybe in Linux, or maybe in macOS, we just can make double click on this folder, and your folder will open. But it doesn't work like it in Linux in command line. You should write command cd, and after it write folder name to open this folder or to change directory. If you don't know what the folder you have in your system, you can look it with command number 2. It is ls command. This command allows to show files and folders in current directory. The next command is rm. If you want to remove file or maybe directory, you can just write command rm, and after it write file name or directory name. But one important thing, you can't remove folder if you have some files inside with this command. But you can remove it if you add a prefix to this command. The next command is mkdir. This command allows to create new directory, so you should write mkdir, and after it new directory name, and you can create new folder with this command. With command move, you can you can, for example, change folder for the file. For example, take file from folder 1 and put it to folder 2. The next command, it is nana. This command allow to open any program and maybe any text in command line, maybe like Microsoft Word in Windows, the same, or maybe any another text editor. So you can write nana and after it file name, and you can change your file inside and the text inside your file. Some people use Vim, but it is a little bit harder, but it has more instruments maybe, but we will use nana. It is easy. It is easy. The next command, it is Python. Python allow start any Python program, and we will use this command all time when we will start programs for autonomous flight, and I think it will be the most popular comment in your lessons. Next is Suda. Suda allow to run any file or maybe any program with super user rights, and it is help useful for maybe special setups in your systems. We will not use it often, but just know this. You can use you can start any program or maybe file with super user rights. Now I think we should try it in our Clover image in virtual machine, and I would like to ask you start your simulator on your computers. I make it too. So you should just double click VMware workstation, and start your image, your system. It can take several minutes to start. So can you please write something in the chat when you start your simulator, your gazebo simulator?
Maybe you should close it
Okay.
and again.
Yes, I will try.
What?
Interesting.
Close it again.
Yes, I will try. Maybe it is some problems with Teams.
Maybe you can
Because,
stop sharing your screen for a minute.
Maybe yes. 1 moment.
Did it work?
It works on my computer, but I can show it in Teams. I don't know why. It works good on my computer, but I can't show it.
Maybe you can choose which windows to stream on Teams.
Maybe, but I'm not sure. Oh, okay. Oh, very good. Finished. So, guys, how are you? Mustafa, very good. Quit, very good. Stoughton, very good. So I think we will start after 1 minute when everybody run gazebo. Okay, Jacques. Okay, very good. Oh, blank ready. Okay. Bruna, good job. So I think we can start. The first one, what you should to do, it is just open Gazebo, double click and waiting for loading. It can take some time because it need a lot of resource. So we can see Aruka map and we can see our drone with LED strip. It works now. We will change some effects for it, maybe today, maybe tomorrow. And we will programming it and you will check it in your simulators. So the first what you need, it is okay. Let's make it. Okay. We need to open terminal, and it is the same terminal what you can see in Clover image. If you input it, if you install it on Real Drone and open it on Raspberry, you can see the same terminal, and we can check Linux commands there right now. The first one will ls command. This command allows to show all folders and all files in this directory. I think so it can be very little front, maybe. Can you see what I
You can try
write
to.
on my screen?
You can press Control
Control what?
plus.
Control plus. Okay.
No, just
No.
Control plus. Doesn't work.
No, it doesn't work.
How
I
about
think
you
you show
zoom?
No,
Yes.
it's just very good. I think it will be more clear. So you can see there all folders and file in this directory. And if I want to open some another directory, I can use cd command. I just write cd space and, for example, Katkin WS. I write this directory name and press tab, and my system write it full. So you can don't write full directory name. You can just write 2 or 3 letter, and if some folder or maybe some file with this name exists, system write full name by itself. So to open this directory, I just press enter, and I can see all files inside this directory with ls command. so I can see there in other files. One more command what we will use, it is cd space point. It allow come back to one folder. And now I change directory to the previous directory. The next command can be mkdir, for example. We can create new directory with this command. For example, it will be programs, and we will save there all programs for today. Now I can see this folder if I write ls command again. So it is it is there. Okay. And now let's open this folder, cd programs. I just write PR and press tab, and system write full name of directory. Now this directory is empty, and if I want to create some files there, or maybe some programs, I will use command nano, and after it I should to write file name. It can be my first program, .py. .py means this program will Python program, and we can launch it with command Python after. So I press enter, and I can see empty area. It is text editor. I can write there something, and it has some commands what you can use in our down path. So you can get help if you press Ctrl G, or you can exit if you press Command X and some another command what you can use. So we will use Python language, and I think a lot of you knows it, but if not, you has homework yesterday with Python tutorial, and I'm sure everybody of you knows what means this command. Print so this command allows to print this string to the screen. Let's check it. For saving this file, you should press Ctrl plus X, and after it, program asks you should it save or not. You should press Y or no. If you don't want to close this file, you can press Ctrl plus C. And now I want to save this file, so I should press Y. And system asks us, should we write this file with standard name, or maybe we want to change name. I don't want to change name for this program, and I just press enter. Now I can see this program, and if I want to start this program, I should just write Python and program name. So we can see our skills Asia string there. Next command. If I want to remove this file or this program, I should use rm command, rm, and I should write file name, what I want to remove. My first program. So now I can't see this file in this folder because I remove it. So I think it's very easy, and a lot people of you worked with Linux before, but if not, you should remember only some most popular command. It is cd, it is ls command, and Python command. So I think it's will enough for you for this course and for using our system. Do you have any question for this or not?
Well, I think you should show us how to remove folder that contains some files.
One moment.
So it's rm-r.
Yes, one moment. Let's create new file in this folder at the first, because if folder will empty, we can remove it just with rm command. But if it contains some files, we can't remove it with just rm. So let's create files there. It can be empty, maybe it can contain something, it doesn't matter. We can change directory to previous, and if I will try remove it with rm command, it say me it can't remove directory, but I can remove it with this command. So it works. This folder doesn't exist anymore. I think that's all what you should know for today and for our lessons. And if you haven't any questions, let's continue. Yes, Timothy?
Yes, let's continue. Okay.
Oh, very interesting. What? So
Okay, so this is the Clover module for Python. Basically, this is the set of libraries and functions that allow you to program Clover. And you can find the link for the link where you can copy this boilerplate. Here, it's on the left. It's either the QR code or the link itself. Julia, you can send it to the chat. Okay, so in this article, you can find the code that you need to copy to your Python file, and then you can use these functions later in this code.
So all these functions described there on this in this article, and you can just read all about these functions, and after it you can use it.
Yeah, and now let's write our first program using this example code here, and I can write it on my screen if you allow me to share.
You can share it by yourself. Just
yes, you just stop sharing. I think I can share.
Okay.
Wait a second. I need to first allow sharing on my computer.
So I think you can open your simulators and write code with Timofey too. I think it will be very good job for you.
I need to restart my Teams, so you can start simulator, and I will connect in a few minutes.
So now let's create a folder and file where we will write our program in Gazebo. So just open terminal again and create folders there. And create a file with your first program.
Hello again. Can you hear me?
Yes.
Okay. And now I will start the simulator myself, and together we will write our first code right in the environment. For some of you, it's not the first at all. For some, it is for the first for Clover. And the screen sharing. Oh, Julia, you have already started to share, yes?
You can start.
All right.
My demonstration will finish when you start.
Wait.
Okay, I can see your virtual machine.
I think I've chosen the wrong screen. Yeah, my simulator is being launched, so wait a little bit more.
if somebody has some problems with Gazebo now, with launching it in your computer, write it please in chat, and I think somebody of us can help with it. Maybe Artem or somebody else.
Looks like I cannot share the virtual machine on Teams.
So if you have problems,
Yeah, I think
maybe
it's
you just write code in VS Code, for example, and after
Alright.
it I passed it in my simulator.
all right. So let's do this way. I'll write it in Sublime Text better because it's easier to set up. Okay.
Just send me.
Oh yeah, I will
you
send
can just send it to general chat, and everybody will have example of code. So.
All right. Okay, so what I basically did is I've created a new file in Sublime Text. It's a free editor. I recommend you using it just instead of a notepad for code. And here we will copy and paste the example code that you just saw. Yeah, I've pasted the code, and I need to change the language to Python, so I do it that way. And now we have a text highlight and auto-completion features, and so on. So what do we do next? We can use all of the functions, all of the services that are provided here. Get telemetry, navigate, navigate global, set position, and some others. If you include them here, you can find them in the documentation. And let's do our first thing. First thing is navigate for taking off. Let me open the article again. I'm going to show you the screen so you can see both of them. Wait a second. Desktop. Desktop. Okay, you can see it right now. So I've copied this example code, and here in API description, I will skip the get telemetry and proceed to the navigate. Yeah, and navigate has X, Y, Z arguments, yaw rate, speed, auto arm, frame ID, and so yeah, this is all of the arguments that navigate has. You don't need to provide all of them, only those that you need. For example, if I want to take off, here is the example take off navigate. You can just copy it and paste to your editor. And notice here that X and Y here, they equal 0, and Z equals 1.5. What does it mean? Remember I told you about frames of reference, the coordinate systems. And here the coordinate system is called body. So this navigate will be relative to the body of the drone. So the drone will ascend like 1.5 meters up and will try not to move along X and Y axis. But fun part is that you don't need to provide the 0 coordinates. You don't have to provide them. For example, if you only want to take off 1.5 meters up, you can just omit using X and Y and have only Z. Z equals 1.5. And now about speed. Speed is 0.5 by default. So even if I delete speed from here, it will still be 0.5. But I want to increase it to be around 1.5 or 1.0, just 1. And now the speed for taking off will be 1 meter per second. The next frame ID equals body is what I need to have here, because by default, this is not body, this is map. And then auto arm, it is false by default. So whenever you don't need to auto arm your drone, you just not write it here. But we need here, and we need auto arm here for taking off. So whenever we have navigate that has auto arm true, you need to know that if the drone was standing without moving its propellers, it will run its propellers. But don't use auto arm true during the flight when the drone is already flying. It is the thing that you just must never do, because whenever you have auto arm true during the flight, in case you need to take over the control with your remote controller, you will not be able to do this, because auto arm also takes back the control to the program. If you made a mistake in your program, you will not be able to avoid troubles. And here we use navigate. Then we need to provide some time for this function. And as you can see, first here's navigate, and it sends this service to the ROS. Then we need to give some time with rospy.sleep function, rospy.sleep. And here we will say, we will paste how many seconds we need to wait. Let's wait, I think 3 seconds will be more than enough. So the drone takes off and hovers a little bit more before the next command. The next command will be also navigate, but we will provide real coordinates in frame ID Aruka map. So let's write it. Navigate x equals, we can say, for example, x equals 0, y equals 1, z equals 1.5. You need to provide it here because we will be using the coordinates relative to the ground, and z should be more than 0 in this case. Then frame ID equals Haruko map. I do not provide auto arm. I can also provide speed because the default 0.5 is quite slow. So let's say speed equals 1. And now the drone will start moving to this coordinate. And let's provide some time for the flight. For rospy.sleep. And I'm sure 2 seconds will be enough, more than enough. So let's keep it 2. Now, let's go to another point. But now I want to use another coordinate system that I've told you today, and it is called navigate target. So what navigate target basically is this is a system that is built from the point that you provided in previous navigate. So this is the point from which the navigate target will be built from. And if I copy this navigate from here and change it the way I want, so use navigate target, and I will need to change these values because I want, for example, to only to only go half a meter down. So it's z equals minus 0.5. The drone will go down for 0.5 meters from where it is standing right now. All right, and it will, let's give it 1 second of the time. And now we can still use ARC map on the next navigate or navigate target if we want. For example, if I want to go to the right, well, depending on how the drone is located, it will be the right or left or anything else. But if I want to go along x-axis, for example, to 2 meters from the place where drone is located, I will need to provide a navigate with x equals 2, y equals 0, z equals 0, and frame ID equals navigate target. So it's 2 meters with a speed of 1 meter per second. I will need to give it a little bit more than 2 seconds, like 2.5 seconds for the flight. And after this, I can use land service. All right, this code is ready and I can send it for the test.
Send it in general chat and I'll already write it in my simulator.
Okay, you can now show us how you test it.
Okay. So I have this code in my system to you. They're all proxy to services, and after it all navigates and landing command. Let's try to start it. To start this program, you should use command Python. Okay, and open our gazebo. Oh,
It
no.
is already open.
It's open at the, yes, I don't, okay. Oh, it's white. I think we can start it again. Oh, no.
Now you have 2 gazebo.
Yes. I will close
Smart.
it now.
I think you should.
So I think we should retry it. So let's start it, and we can see how our drone.
You need to stop this the terminal. Stop the last terminal from gazebo. Control C.
Yes. 1 second.
Now you need to restart.
Yes, I just restarted. Yes, it has. Waiting for launching. And if somebody already started in your terminal, you can write plus in chat too.
Did your gazebo launch or?
Nope, it's just launching.
I think you need to Control C in all gazebo windows again.
You think restart the system? Nope.
No, just try to press Control C here.
Wait.
You want to restart?
Yes.
No, you don't need to restart it that way. Don't close Windows. It's
Just
bad.
Control C.
Yeah, always Control C and never close them.
Yes, it's okay.
Now it's okay.
Works. Yes, I know it works. It's my my way, my own way. So let's start program again. And we can see how it turn on propellers and motors and fly to first navigate and second navigate and land. I think it was very big speed for so little distance.
You can change it to the 0.5.
Yes, let's change it. Okay. And let's make a distance some more maybe. So don't forget, if you make distance more, use and speed less, don't forget about time, because you need more time for the section. For example, to fly on 2 meters with speed 0.5 meters per second, you need 4 seconds for the section. And maybe 0.2 and maybe 0.2. So
And let's show them how to edit programs in Visual Studio Code and Simulator.
yes, maybe. So let's start it again.
Let's
maybe.
test first, and then let's show them.
Yes. So it will fly to. It will fly with with less speed and to another points.
Okay, can you open the folder with this program?
Yes, of course.
But not in the terminal, but in the Explorer.
Okay, yes.
So home on the left.
Yes.
And
here it is there. It's right there.
Yeah, and if you right click and open it with Visual Studio Code.
Okay. Yes.
You will have the interface for editing this program. And here we can edit everything we want, and it also highlights some possible errors and actual errors.
You can copy and paste all what you want there.
Yeah, so you can copy it on your Windows and paste on your Linux. It works that way, and both ways.
Yes.
So you can copy a program from your simulator to your Windows or Mac OS.
So I
guys,
can
guys,
say yes.
Yulia, just a moment.
Yes.
Could you make the zoom in on the Visual Studio and on the terminal? It helps us to get the best view on the streaming and on the record.
It's
View zoom in. It's for terminal.
I can zoom. I can zoom terminal, but I don't know how to make it fast in Control Plus.
Control Plus.
Yes, it works in Control Plus
great.
works in VS Code, but it doesn't work in terminal. Yes. So
great,
there is the same code actually. It is a file what we open it in our terminal, and if we make some changes in this file, all changes will be saved there. Let's try it. Just maybe let's take off to 5 meters, no, 3 meters and half.
And can I try to get the control of your computer?
I think no, I don't sure. Yes, you can. Yes.
I don't think it works.
It works. I see
it works,
your.
But whenever I click something, it doesn't click. And no, it doesn't control anything.
Let's try again. I don't sure you can make it with Teams.
Well, all right, but can you make changes and then just play it with this green play button?
Yes. Okay. Yes.
Easy, fun way to test programs. Can I stop the control? Yes.
I don't know.
Okay, I stopped it. So when you change your files in Visual Studio Code, you can actually run them from there by pressing this green button.
Yes. And you can see it in Gazebo too. So you can start your code from terminal or from Gazebo, because it is the same. It is one system, and you can change files there. But be careful, it's impossible only. It's possible only in Gazebo simulator. In real drone, you will have only terminal on Raspberry. But you can use some another program to upload files in Raspberry. For example, you can any SFTP client, or maybe you can use PyCharm and upload files and your programs from PyCharm to Raspberry. It will be work too. But there we can write program in terminal and upload it and start it, or we can write it in Visual Studio Code and run it there. You can check it too on your computers. So I think we have some practice for you, and you can try it by yourself after little relax time. So I think so. I think we need a little coffee break time, And after it, we will come back and we will try to write your own programs and we will try to work with Gazebo simulator. I'll see you in 10 minutes.
I see the question in the chat. So why did we use ArucoMap in FrameID? Well, we used ArucoMap, I think, once in our code, and then we used navigate target. So whenever we navigate with ArucoMap, it means that we want to go to the coordinates relatively to the original point of ArucoMap. So we provided something like 0x, 1y, and 1.5z. So it means just that we we move our drone to these coordinates relatively to the Aruco marker field. And from whenever the drone is located, it will go to this particular point. It can go back, forth, right, up and down, but to this particular point in the Aruco map. But when we use navigate target, we the point from where we calculate our position will be different all the times, depending on the previous navigate. I hope it is helpful and you can just test it yourself. You'll have the simulator. Yeah, no problem. See you in 10 minutes.
So I think we can discuss again some questions there, and after it, we have a little task for you. I hope everybody come back. So guys, are you ready? Write plus to the chat if you're ready. Okay.
All right, let's
It's
go.
like okay, very good. So again, what about Aruka map and about body? You should start your programming career for Clover. I think you should use only body frame and Aruka map frame, and don't use navigate target if you don't understand now how it works. You should just use body to take off, and you should use Aruka map for all flight. In Aruka map, you can fly to any points on the map. You can fly there on there if you know coordinates X, Y, and Z. So you should use only Aruka map when you fly, and you should only body if you take off. It's enough for this time, but after it, if it will be clear for you, I think we can add to this program, for example, navigate target, but a little, but maybe in the next days. So for today, you should use only body and only Aruka map. What about creating Aruka map? It was a lot questions in our chat in Telegram. So I think we tell you about how create it in this image in Clover, and how create it in Gazebo and in Raildrone, and how create it for printing for real flights with Raildrones. But it will be tomorrow, I think. And now let's work with just programming. And I think I hope you understand previous code and previous program. And I think you can write your own program in Gazebo and share your success to chat. So I think we have 10 minutes to you open your Gazebo simulator and write your own program. Your drone should take off to 1 meter, and after it navigate to point with coordinates 1, 1, 1.5, and after it then land. So the first take off, then navigate, and then land. I hope it will be easy for you. You can start now. You have 10 minutes for this task, and if it will be successful, please share your result to chat, video maybe, or maybe photo. So let's start. Let's play.
And for those who think this is too easy, you can impress us with your own versions of this program. You can include some more advanced flight paths and show us the result. Like flying not only to the point 1115, but some other points as well.
So Ghazali, I can show your code in simulator now. So it's flight, very good. Oh, Bruno, very good. So I hope you finished this task. I saw Bruna finished and Ghazali and Subai finished too. And it's very good job, guys. And I think we can continue. If you're ready, please write something to the chat. If you finished this task already. Okay, let's go. So, one more interesting thing, it is get telemetry service. So this service allow us to get position of drone under the Aruka map and get all speeds and all angles, and you can use it through terminal, or you can use it through your code. And so how it works: if drone see Aruka map, it can get coordinates XYZ, and it can show voltage on cells and all angles, roll, pitch, yaw, and speeds by XYZ, and attitude. So all these parameters you can get through easy command service call get telemetry Aruka map. But it can work only when drawn under the Aruka map, and when it saw Aruka map. Let's try to get coordinates in our simulator. First, maybe I will show you one thing. I think it works there. I hope it works there. Or not. Works. Okay. So if we want to get coordinates, at first we should tick off to drone start see all markers. For it, we can use the service from terminal, for example. I can ask my drone take off from command line. If I will use the service call navigate, and I press tab, navigate, just navigate. And there we can see all parameters like in Python commands. And I can write there hike by z 1 meters and speed 0.5 meter per second, and frame ID I will use body, and I should to arm my drone, so this parameter must be true. So this command allow to take off drone from command line. So we can see how it take off. Very good. So now drone can see markers, and it can get his coordinates. How we can get it? Got it. I should write command service call get telemetry, and press tab again and write their Aruka map. And press enter. So now it has coordinates by x0 and 0.75 meters. It is by x, 1 meters by y, and 1 meters and 10 centimeters by z. It has speed near 0, but it by x, y, and z. But it tried to keep his position and correct his position in real time. So it has speed by x, y, and z, and because it isn't just 0, but it is 0.04, for example. And you can see pitch, roll, yaw parameters, and voltage on battery, and each cell's voltage. You can use these parameters in real polygon to get position of drone, or to get positions of some object on polygon. For example, if you have 3 points where you want to fly, you can take drone and put it under these points step by step, and to get telemetries from these points, from 3 points, and take these coordinates and put it in your code. We can just copy it from this place and paste it to our code. I will open it with Visual Studio. So I can pass these coordinates to my code. So x coordinates I can pass to x. Y coordinate I can pass to y. Oh, I lose my mouse. So you shouldn't take a lot numbers after point because it hasn't so much accurately really. Yeah. So it's very strange. Okay. I can load this code and drawn tick off to one to this. Okay, I write it. And it tick off from current position to half meters, and after it return to kike 1 and 1.5 meters, and to coordinates where it is now. Let's check it. So it's tick off a little bit and return to previous position where it was, and after it it continue previous code. So I think it is a very useful service, and you can use it like in a terminal and in a real world, in any competition you will use it. So just remember it. But I can use it not only through terminal, I can use it from my code. For example, I will change Ghazali's code. I can use the service from my code, from Python program. And what I should to do. The first, after when I take off, I can write Cilium equals get telemetry Aruka map, and I can print this print some parameters from telemetry to the screen. For example, I can show telem.x, and I can take any parameters from telemetry if I write their names. For example, if I want to get x coordinate, I just write telem.x. The same way for y and for z, for y and for z. So now it will show us coordinate where it's placed. I'm sorry, some problems with my mouse. So let's check it again. I start program and it takes off.
Start it again.
So I want to, I have some problems with my mouse. I'm sorry. Timofey, can you ask my screen access? Oh, I means I think I can't give you access. I'm sorry, some technical problems. 1 minute. Okay, I fixed my problem with mouse. So now I restart it. Okay. Okay, it's okay. Oh no. So now our drone will take off, and after it show us its telemetry, its X, Y, and Z coordinates. It's takeoff, and we can see his coordinates X, Y, and Z. So, okay, and you can use it when you want to fly to any points, and after it come back to start points. For example, I can make navigate to any points, and after it come back to start point. For example, I will fly to 6 meters by X, 5 meters by Y, and after it, I will navigate to Chelem dot X, Chelem dot Y, dot Y. I'm sorry. And I think it will be flat. it can be just string, I'm afraid. So let's check it. So it's fly to points 6 and 7 by x and y, and come back to start points, and after it land. So this way, how to get x, y, and z coordinates from Aruka map, and how to use it in your code. Let's continue. I think now Timofey can show you how to.
Yes.
How to programming drone for flight. I'm sorry. For flight to to points in the Aruka map, but if you don't know how many times you need to fly to these points, and you don't want to calculate it, you can just use navigate weight command, and Timofey can tell you about it.
Yes, and before you send the code to the chat, you don't need to change the type to float, because it's already float when you get telemetry. So
it's float, yes? It
already,
isn't a string, yes? It's
yes,
already float. Okay.
All right, so this is an example function called navigate weight. Why do we even need to use it? You remember that every time you use navigate, you need to provide some ROSPY sleep time for the drone to being able to fly to this point without interruption. But we don't always want to calculate the time we need manually, or we don't always know how much time it takes to fly from point A to point B. For example, if we place a drone on a different place in the Aruka marker field before we take off, it will take a different time to fly from one point to the particular coordinates. It takes different time to fly from different points. So we need to have function that just all it does is wait for the drone to reach the place it needs to be, and this is called navigate wait. Here is a little bit modified example that you can find on the knowledge base clover.coex.tech. I will show you where to find this code and how to modify it for ease of use. And I will show you how to implement this code. Is this snippet in your code, and how to use it. Okay, I will share my screen right now if I have such option. Wait a second. All right, do you see my screen?
Yes.
Okay, so where do we find this code example? Let's proceed to the code snippets article. This article contains some pieces of code that can be useful for you to learn more, to implement some functionalities, and so on. For example, here you can find the fly along a circular path and many other things. But I think I'm looking for the snippet that's called flying towards a point and waiting for copter's arrival. All right, so this snippet, this actually includes 3 code snippets. Like this is the first one, this is the second one, and this is the third one, the most advanced and easy. We will begin with this one. So let's copy the code from the article and open our code. So this is the code that I just wrote recently. You all remember it. And I paste the function right below the services. Okay. And for those of you who cannot find the article, I will send you the link to the chat. So, okay, here is the link. You can all now find this code example here. Let's go back to the text editor. So what this code does. First, as it is a function, it has like the body of the function, which is these lines of code, and the arguments that are given here. The arguments are XYZ, speed, frame ID, tolerance, which is something new. And I will also include auto arm as the last argument, because we need to be able to take off using this function as well as flying towards a point when we are already in the air. So let's do just that. So press comma, then auto arm equals false, because we don't want it to be true by default. And here, the first navigate that is performed in this function, it doesn't contain auto arm true or false, so we need to provide it here. Let's edit that way. Auto arm equals auto arm. So what it does is it gives the argument auto arm, the argument from the navigate service. We give it the value from the navigate wait function, which is false by default. And if we need to change it, we will write auto arm equals true whenever we call this function. Okay, then let's provide default values for XYZ, speed, and frame ID, because we don't want to write it manually every time we call the function. So frame ID is arrow command, speed is 1, and Z is 1.5, X is 0, Y is 0. All right, now we have default values, and we can just call navigate wait function very easily. I will delete for now all the code below because it is outdated, and I will write this in a new modern way using the navigate wait function. So how to take off? Let's write navigate wait, and we need to change frame ID to body and auto arm to true. All the other arguments will remain the same. Frame ID equals body, auto arm equals true, and this is the only line to take off that needs to be written to take off and at the height of 1.5 meters. Once it reaches this height, it will proceed to the next navigate wait function. All right, and if I call navigate wait without any arguments provided, it will use all the default arguments, such as x equals 0, y equals 0, z equals 1.5, frame ID equals argmap, and no auto arm. So I will leave it here because I want to make sure that my program begins to execute from the position just above the 0, 0 coordinates. So right in these coordinates. And now we can use navigate weight and fly to any point using any frame of reference. For example, let's go to the coordinates 4, 4, 2. And we know that it is already ArcMap. And these coordinates will be the same every time we run the program. The drone will go to exactly this position every time. But now I want to navigate using the other frame of reference, which is called navigate target. So I will show you how easy it is to change frames on the fly. Let's say I want to fly up to 2 meters from the place the drone will be and is in this time. So I only need to say z equals 2. I want to take off 2 more meters up, and the frame ID will be navigate target. All right. So the drone will go up 2 meters using the navigate target frame. From that point, we can go back to the 0 coordinates using just normal navigate weight without any arguments given and land in this place. Okay, this code looks fine. I will send it to Julia for the test. But just before we test it, I need to come to the remaining of this code because I didn't, for those of you who are new, you don't know what it does. So first thing it does is enters the infinite while loop. So this loop will only end if certain conditions are met. So what it actually does, while not respy is shut down, is just the way that you write infinite while loops in ROS. Just remember how to write it, and don't write while true because this will cause you problems later. Only write while not respy is shut down. Then what it loop does, first it takes telemetry, like get telem equals get telemetry, frame ID equals navigate target, which is what Julia showed you. And then the condition, if math sqrt telem x squared plus telem y squared plus telem z squared less than tolerance. Do you remember the tasks, the home task from yesterday? You needed to find the distance between 2 points. And here is the code that actually does that in a more easy way, because when we get telemetry using frame ID navigate target, it will give us how many meters we still have left to fly to this point where we are navigating right now along each axis. For example, if we just started traveling to this position that's given here, and we are 10 meters away from it, when we get telemetry with this frame ID, we get like x equals, for example, minus 10, y equals minus 0.5, and z equals 0, just for example. And it means that we are not in this position yet. Navigate target is where we are heading towards. But whenever we are very close to the position that we are flying to, you understand that x will be approximately 0, y is around 0, and z around 0 as well. So math SQRT just calculates this distance and compares it to tolerance, which is the area that we, like the distance that we think that it's just enough to think that we already have reached the point. In this case, it's 0.2 meters, like 20 centimeters. And it says if we are 20 centimeters near the point that we are heading to, then we can proceed to the next point. All right. And if this condition is met, we break the while loop. So the while loop will not repeat again. But if the condition isn't met, we just go to the remaining line of this while loop, which is Rospy sleep, and wait like 0.2 of a second. Then then we repeat the process, we get another telemetry and compare it once again. All right, I hope it is. I hope you understood it. And now let's finally test this code. All right, Yulia, you can copy and paste this code.
Okay. One second. So I passed it. I passed this code to my gazebo, to my program, and now I will try to start it. So gazebo is okay, it's ready. So I just started from Visual Studio Code. It is, and it is.
Yeah, we
it
forgot
has,
to import math.
Yes, it's very important to import all libraries what you use in code. So this library allows us to use mathematics operations like to get absolute, or maybe to get square, or maybe to get sinus or cosinus of this number, this angle. So let's start again, and I add this library, and it's run. Okay, it's run and it's flight. Oh. Oh, it's flat up. I think we can repeat it. Not. Oi? Not sure. Yay. Someone else. I break it a little bit. um,
Now you need to restart the drone.
Yes, I think you're right. Okay. So I will restart it. Let's check it again. I just started from my Visual Studio, and we can see how it flies. Okay, that's finished. I think it isn't easy and clear for understanding, but it is very useful for your code. And if you understand how it works, it will be easy for you write any code for autonomous flight, I think. So let's continue. Timothy, did you finish with it or not?
Yeah, the part with navigate target is finished. The question was from, I see the question in the chat. Well, the difference is the arguments that you provide to the navigate weight. Just look at the code again. Well, if you see the navigate weight with empty parameters, it means that in this place, you will call the function navigate weight with default values. The default
This
values.
is x0, y0, z1.5.
Yeah, Judah, we don't see the code for some reason.
You can. Okay, I'm sorry. 1 second.
So the default values that I've provided when I defined the function. The navigate weight 442 is actually 4 will be x, another 4 will be y, and the last 4 and the 2 will be z, because this is the order in which we provide our arguments in when defined function. The navigate weight where z equals 2, frame ID equals navigate target, not target as you wrote, the target with t on the end. Well, it means that we skip x and y and proceed to z and say z is 2, and then proceed to frame ID and say that frame ID equals navigate target. So whenever we run this command, we will see, well, the navigate will use the navigate target frame ID. And the last navigate weight x equals 4, y equals 4, z equals 2. Well, this is, I think this is what you wrote yourself. You can write it that way, but it's easier to write just 4, 4, 2 when you use first 3 arguments, because just less symbols to type. And this is a correct way to flying to these coordinates, but you need to understand that this is not the same as navigate using ArcoMap frame ID. So when you go to 442 with ArcoMap, it's always the same spot on the map. But when you use navigate weight with 4, 4, 2 and frame ID navigate target, the drone will always go 4 meters to the X, 4 meters to the Y, and 2 meters up every time whenever you call this function with these parameters. So, like for example, if you have 10 navigate weights with these values, your drone will fly 40 meters to the X, 40 meters to Y, and 20 up. All right. Hope it helps. Let's go to the next slide.
So we have a coffee break, but I think we have not so many time to finish our lesson. So we have for today only let's trip indication, and if you want, we can make a coffee break, but if not, we can just continue and finish in time. If you don't tired. Okay. Let's trip. We can change let's trip indication on our drone, and we can see it in Gazebo Simulator 2. Oh, how it works. Now we can see pink LED indication on our drone, and if we want to change it, we should find this we should find code in Gitbook. And we can
But
find.
it's still a great gray screen, and we don't see it.
Oh, okay. I'm
Sure.
sorry. One moment. What about now? Can you see my screen now?
Yes, but not the Gitbook.
Okay. So the first I showed drone with LED strip. We can see it on our drone, and it is pink. Oh. Что такое? Ah. Where is my drone? No. Oh, it is there. So we can see pink rainbow, and now we will try to change it. At first, we should.
Julia, when you switch to
yes,
browser,
okay,
you can
understand.
see it.
Yes, I understand. We should open Gitbook and find article with let's trip, and there are some setups, but it already set up on your in your Gazebo, and we can just start use all services and all commands from this Python example. At first, we should import setlet effects because Raspberry is imported already. And we should pass it to what? So now I will pass it to Timofey's code, okay? With navigate weight.
Mm-hmm.
So I make import setlet effect, and after it, I Wait a minute. And after it, I import. It is imported already too, and I can just copy this code. So I will paste it before takeoff and after navigate wait function. So the first string, it is proxy service call. So I put it to all to all proxy service calls. And so what we change? We passed import setlet effect, and after it we passed call of service proxy to set effect, and after it we just can use command set effect to change colors of our LED strip. There we can change colors, and we can change effects. What about colors? We have three value. It is R and G and B values. R means red, G means green, and B means blue. If we want to make to turn off our LED strip, we just set up all values to 0. It means black light, but we haven't. We can't have black light, so we just turn off our LED strip. If we want make white color, and we can set up all values to the same value. For example, 255, it is max value, and it will be highest light brightness. So it will be white color. And if I want make red color, I just write there 255, and to green I write 0, and to blue I write 0. It will be red color. If I want mix colors, for example, I can make purple. For it, I can write red, for example, 150, and blue 100, and it will be purple. We can use some effects too. For example, some blinks or rainbow in our LED strip. Let's check how it works in simulator. I just started and open my gazebo. So there's some problem. I think I should make. I should give more time for these effects. So we can see blue color. Now it is this blue, what, this string, and after it we can white blink is the string when our LED strip blink with white color, and the next one it is rainbow when all LED strip change its colors, and after it start our program. We can use all these effects in any part of our program. For example, before takeoff, I can turn on our LED strip with purple color, and after takeoff, I can make another color, and after it I can make another color, so I can set any color in any time in my code, in any time in program. So that's all. It is easy part of our study, and you can try it by yourself in your homework. So now for you today homework, I have some tasks. The first one, it is write program started in Gazebo with Let's Drip and with navigate wait function. So you should write program, and this program should allow to drone take off, and then turn on green LED strip indication, then fly to any 4 points with navigate wait function, and then land. And if you finish this task early, you can make yesterday's homework in Gazebo, like it makes Mustafa today. So yesterday you just write simple Python code, and today you can make it with flight, for example, if you have time. And we have two fast students who work very good, and they know a lot about programming and programming drones too. So we have a special task for them. It is the students Jacques and Mustafa, and they should write code for flip, like we showed yesterday in our videos. And I hope you can make it if you will use this link. And yes, we have Jacques asked me today about different between EKF2 and LPE, and I will tell you about it little bit, and I will tell you about it after these lessons. But when you will make code for flip, you will change some parameters in drone setups, and if you will have some problems, you can ask Timofey how to do it. So for all guys, it is write code to take off for Jacques and Mustafa to write the code for Flip. I hope it will be easy. And that's all from me. Maybe Timofey wants to say something?
Well, I hope all of you try to work with this flip code because it is very fun. And about the parameters, you don't need to change parameters in QGround control, but instead change the parameters in the code itself. So there are a few things that you can change. Try to understand how it works and find out what to change to make it work the way that it doesn't fall on the floor after flipping. That's it. Good luck.
Oh, Svetlana.
Hey, hey, hey! How are you guys? I hope you feel very well myself. Where is videos? Oh, okay. Yulia, could you stop this sharing your screen? Okay, great. So I'm glad to see you again. I see your smile and see you don't tired faces. I hope it. Okay, so our evening brief will be finished in 2 minutes. Some presentation. Just a moment, I share in my screen. Yeah, I have some news for you, of course. Yep. Yeah. Okay, great. So many thanks for our teachers, for Yulia, for you, for Timofey, for this interesting lesson. So please leave your feedback using our special form, the link in the pinned message on our common Telegram group. Don't forget about it. The simple is easy, simple, but it's help us to make next day more useful, more better. Next, I would like to remind you about our tomorrow and after tomorrow meetings. We will start in 10 o'clock using these links. All links will be pinned into our Telegram group chat. And next, of course, don't forget about homework. We prepared a journal with marks. Yulia Timofey will be provide assessment to you, your homework and your performance task. And I would like to offer you to participate in our Photo Gazebo challenge. You can take and share your amazing photos during the camp. Feel free to share it. And in the last day, it will be after tomorrow. We create a collage of photos, and it will be funny, I think. So this is my first photo, and I shared with you my selfie with gazebo. So like and share and support me, and share your photos on the Telegram or on your social sites such as
This is
Instagram or
Gazebo.
Facebook.
Gazebo. You have
Gazebo.
and a gazebo.
Gazebo. Okay, gazebo. Okay, I think we can finish for today. And see you tomorrow. Maybe if you have any question or discuss, we can discuss it, or we can finish. Okay, I see. Okay, great. Yes, I know my photos was amazing. Thank you. So, guys, see you tomorrow, and have a good day. Have a good evening. For Brazil especially, and for Portugal and for Ghana too. Okay, guys, thank you very much, and bye-bye.
Thank you, everyone. Bye-bye.